So now we are starting with algebra, lecture number 18. So let me just write it over here. This is algebra, and we are on sketches. So this is lecture number 18, and I think it's the third lecture of sketches. So now last time what we did is that we went through the transformation of these power functions. So this is the power graph that you see over here that is about an exponential growth. The base is positive. The base does not equal to 1. 2 raised to power of x, that is like doubling. 3 raised to power of x, that is like tripling it, and so on. Half raised to power of x, that is like halving it, and so on. So these are the graphs that we did last time. And before that, we went over the quadratics and all these things. So now this is where this particular page is. And where are we exactly? So we have done linear, quadratic, cubic. Let's focus on this cubic. Let's focus on this cubic. And then reciprocal, something like this. This is what we have to focus. So let me just copy this thing. And let's go all the way to this page. That's right over here. So let me write it over here. And the focus is on the following. Let me highlight it. So cubic, that's part C. And in cubic, we are interested in these two things. Then we will move on to reciprocal. We have done the basic reciprocal, but this is reciprocal in which there is a bit of transformation. Y is equals to m over x plus n. And this exponential is already done. So this one is exponential, that's already done. Knowledge of turning points, vertical and horizontal asymptotes, roots and symmetry is required wherever possible. Finding turning points of quadratics, this is already done. So this is done, this is done, this is done, and so on. So now these two and this one, that is what we are focusing on. So now if I talk about cubic, let me add a lot of pages over here. And we talked about the basic cubic early on, but this is about a little bit more. So I'll just wait for the azan. Just hold for a second. So over here, we are starting with this thing, which is cubic. So let me highlight this. This is cubic function. So y is equals to x cubed. If x is positive, y is positive. If x is negative, y is negative. And we have drawn this curve earlier. So let me just draw a grid over here. So I'm just drawing this thing right over here. And let me just copy this thing. Okay. So the two basic cubic curves are such and such. That is over here. It's the arrowhead. The first one is this thing. When x is positive, y is positive. That goes like this. When x is negative, y is negative. That's the graph. Let me draw it a bit longer. And let me write over here, y is equals to x raised to power of 3. And over here, this particular graph that I'm drawing, that goes like this. This is y is equals to negative x cubed. So now we know that whenever there is a negative sign, that is reflection of y is equals to x cubed in x-axis. So that is the basic graph of y is equals to x cubed and y is equals to x raised to power of negative 3. Now, if I draw it over here, let me add some constants over here, something like this. If I want to draw y is equals to x cubed plus 1, and over here y is equals to x cubed minus 2. Now the original x cubed, the red one, let me draw it first. So the red one that goes like this, and plus 1. So the graph is shifted. Let me just copy this portion. And this portion is this one, and it has been shifted up by 1 unit, something like this. Okay, not exactly the same thing. Let me just draw it. Okay, so that is this one, and that's how the graph is drawn. So this one and this portion right over here, we know that when it is plus 1, the graph is shifted vertically up. So let me just change the color. Let me make it purple. Let me make it purple. That's like this. So the purple graph, that is y is equals to x cubed plus 1. What has been shifted? This was the obvious point, which is 0, 0. It is now shifted to 0, 1. So that's how the graph is drawn. This is y is equals to x cubed. This purple one, y is equals to x cubed plus 1. Now the next one, y is equals to x cubed minus 2. Or let me just change the equation and let me write this thing as minus x cubed plus 2. Now this blue one is negative x cubed. So let me just copy this. And this is negative x cubed. That's right over here. And this is also negative x cubed. This is not drawn as one piece. That's why I have to copy it twice. This is the original one like this. Looks beautiful. And minus x cubed plus 2. So this is the blue one like this. This is minus x cubed. And the pinkish one, that is minus x cubed plus 2. Let me copy this. And let me add 2 units more. Something like this. Let me change the color. This is minus x cubed plus 2. Similarly, this one over here, copy, paste. And over here, let me change the color. This is minus x cubed plus 2. Again, mark the obvious point. This is 0, 0, and this one is 0, 2. That's the y-axis, that is the x-axis, that is the y-axis, that is the x-axis. Now, these graphs are of this format. This is y is equals to ax cubed plus t. We talked about ax cubed. We talked about ax cubed when we were doing it, the original graph, y is equals to 2x cubed, y is equals to 3x cubed. It becomes more steeper. And over here, it becomes more steeper. So let me also show that thing over here so that everything falls in one place. Not this thing. Let me draw the grid. So that is over here. That's right over here. Okay. So now y is equals to 2x cubed. And over here, let me draw y is equals to half x cubed. Now the original one, that's right over here. So I can draw another one. The original y is equals to x cubed, black marker. And this time I'm drawing the original one in purple color. So that's the original one. and 2x cubed, the reddish one, that is more steeper, like this. So this is y is equals to x cubed. This is y is equals to 2x cubed. In general, if I have y is equals to kx cubed, if k is greater than 1, the graph gets more steeper towards y-axis. Now over here, I'm interested in half x cubed. So let me just choose this purple one. Let's copy it. And it goes like this. And over here, let me copy this. And now half x cubed in blue color. No, not this thing. Let me get this thing ready. And this goes like this. So now y is equals to half x cubed. Again, this is the original one, x cubed. This is y is equals to half x cubed. It gets more flatter towards x-axis. That means if I'm talking about the same thing, so now this is the reddish thing. Let me just clear this thing. So the original one is the purple one. If k is greater than 1, it's more steeper towards y-axis. And similarly, if I'm talking about this blue graph, so this is k lying between 0 and 1. This is more flatter towards x-axis. Now, someone can ask this question, what if k is lesser than -1? That means I'm interested. Let me draw it over here. So, and I'll give you time to copy it down. Otherwise, it's kind of like bulky. So it will become difficult for you to retain all this knowledge. So let me just write it over here. So now I'm interested in drawing y is equals to -2x cubed. I'm interested in drawing y is equals to negative half x cubed. So -2x cubed is basically the same thing as 2x cubed and flipping it in the x-axis. This goes like this goes like this. So basically, it is a combination of two things. Not only it's more steeper towards the y-axis, it's flipped in the x-axis. Let me write it down. So because of this two, this is more steeper towards y-axis, and at the same time, it's then flipped in x-axis. Flipped is reflected, okay? So let me use the right terminology so that there is no confusion with the examiner. And because of this negative sign and reflected in x-axis. So let me draw the graph, the original one, that is the purple color. So if I draw the original one, so let me just draw everything again. This one and this one, that is the original one. Over here, this one and this one, that is the original one. And then there is negative 2x cubed. So instead of these things, let me just erase this. Let me draw this one. That is negative x cubed. Like this. And that is negative x cubed. Like this. And then what is happening? It is more steeper. So red one is more steeper. So it's like this and like this. And over here, half x cubed, it is less steeper. So let me first erase this, erase this. Let me choose a purple color. Okay, so now it's time for the labeling. The purple one, y is equals to negative x cube. This is y is equals to negative 2x cube. This is y is equals to negative x cube. This is y is equals to negative half x cube. Just have a good look at it. If k is greater than 1, it's more steeper towards y-axis. Yes, it's more steeper, but it's also reflected in x-axis. This is more flatter. So over here, this is more flatter towards x-axis and is flipped or reflected in x-axis. Now let me pause the recording and I'll wait for you people to answer whether you have understood it thoroughly or not. So now people, it's time to recap what we have done so far. I know sketching is not the easiest of thing that people come across, but don't worry, we will get over this thing very soon. The original thing, the OG is y is equals to x cube. If x is positive, y is positive. X is positive, y is positive. So that is why it's drawn over here. When x is negative, y is negative. That's why it's drawn over here. Remember, this is the 18th lecture. So in the initial lectures, I think maybe like 13 or 14, I'll just share all the links. There is this original graph explained. I have done the explanation, but still it's explained over there also. When y is equals to negative x cube, it's a reflection of y is equals to x cube and x-axis. So these are the two original ones. The first thing, this is like a translation. So this is the concept of translation. That means if y is equals to x cube plus minus a constant, if it's plus k, it moves up. If it's negative k, it moves down. K itself is positive. So over here, this is x cube plus 1. The graph, the whole graph is shifted. Graph is a collection of points. So the whole graph is shifted 1 unit up. This is the most prominent point. 0, 0 gets shifted to 0, 1. Similarly, y is equals to negative x cube plus 2. So this is the graph of negative x cube. This is shifted 2 units up. So 0, 0, the point through the origin itself becomes 0, 2. So these are the two basic graphs. These both relate to translation. Now, what is this thing? This one, this transformation, this is called a stretch. Y is equals to ax cube. Actually, I've written it downstairs. So this is stretch and this is parallel to y-axis. What we do is that we just stretch it along the y-axis. Let's say if I choose the value 2, the cube of 2 is 8. But now because of 2x cube, I'll multiply this by 2 and this will get 16. So basically the height increases. The 0 will remain as 0, but every other point it has increased. So therefore, when y is equals to kx cube, if k is greater than 1, like k is 2 or k is 1000, the graph gets more steeper towards y-axis. So that's like over here. This is more steeper. This is more steeper. If k lies between 0 and 1, it's still positive, but it's like half or 1/3 or 3/4 or 2/5 or 1/7, something like that. It gets more flatter towards x-axis. So again, this is the original one. And if it gets more flatter, that means the height decreases. For example, if this point is 2 and this point is 8. So now over here, half of 8 comes out to be 4. That's the logic that's applied over here. Now, what is this thing? This is the thing in which what we have done is that this is also y is equals to kx cube. If you want to write it separately, I can help you with that. If k is lesser than -1, so what is happening is that we are either you can compare it with y is equals to 2x cube, or you can just compare it with y is equals to negative x cube. So let me just compare it with y is equals to negative x cube. So hold for a second. What I'll do is that let me write over here y is equals to k multiplied with negative x cube. Now over here, this k is this 2. So again, it's more steeper towards the y-axis, but we are transforming negative x cube. So take the graph of negative x cube and make it more steeper. That is an easy way. If I compare it with the original x cube, what is happening? That's more steeper towards y-axis, and then it's reflected. So it all depends how do you want to compare it. So let me explain it again. If you want to compare it with y is equals to x cube, you first stretch it and then you flip it, something like this. That's one approach. The other approach is this. We have y is equals to negative x cube. Just make it more steeper. I think this is the easier option. So I think I'll go with this thing and I'll choose just apply the same concept as before. If k is greater than 1, so just remove the negative sign, just remove the x cube. This thing is greater than 1, it becomes more steeper. And if this number is a fraction, it gets more flat. Is this thing all good, all clear? So now cubic is done. Now what are we waiting for? We are waiting for this. That is y is equals to ax cube plus bx square plus cx. It's still cubic, but it's a different kind of cubic. So y is equals to ax cube plus bx square plus cx, which can be written as x common, ax square plus bx plus c. We have something like this. Now, when we are talking about the curve like this, what happens is that if I make y is equals to 0, therefore x bracket ax square plus bx plus c equals to 0. In other words, we have this x equals to 0, and then we have this thing, which is ax square plus bx plus c equals to 0. And we will get the x-intercepts, and we should be aware of the terminology. X-intercepts are also known as roots of equation. So now this is the new kind that we are starting with. Y is equals to ax cube plus bx square plus cx. This is the new kind of cubic equation. Now let me create something like this. So let me write y is equals to x, and this is x squared, and this is minus 5x plus 6. How will we sketch this? First of all, focus on this. Let's factorize. If I factorize this thing just this much, so that is x squared minus 5x plus 6. That is x squared minus 2x minus 3x plus 6. That is x bracket x minus 2 minus 3 bracket x minus 2. This is all middle term factorization. So this is x minus 2, x minus 3. So this is x minus 2, this is x minus 3. This is known as factorized form of quadratic of cubic equation. Now, the very first thing that I'm interested in, what are the roots of this cubic equation? Y is equals to 0. Therefore, x bracket x minus 2 bracket x minus 3 equals to 0. Therefore, x is 0. Therefore, x is 2. Therefore, x is 3. These are the three roots. So we say that there are three roots of this equation. Now, the next thing that I need to focus is the coefficient of x cubed. So maybe this question originally was given as x cubed minus 5x squared plus 6x. So coefficient of x cubed is positive. Now we have the original graph. Let me take you back over here. That is the original graph of y is equals to x cubed. It starts from the top right. It goes till bottom left. So this is top right. Let me write over here. This is top right. This is bottom left. That's what happens when x cube is positive. And if x cube is negative, this is top left and this is bottom right. That's how the graph will travel, like this and like this. So going back to this point, when coefficient of x cube is positive, the graph will be starting from top right and going till bottom left. But at the same time, it has to pass through these 3 points. So let me just get the grid ready. And now it would be like this. This is 1 point. This is the point 2, and this is the point 3. So this is 2, and this is 3. So let me just elaborate this. This is 2, this is 3. This is 2, this is 3, this is 0. Now the curve has to pass through these 2 points, and it should be going like this. Because this is top right, this is bottom left. At the same time, it has to pass through these 3 roots. So let me just draw it like this. So this one goes like this, and it goes like this. Not exactly like this. Okay, let me make it more steeper. Okay, I think that would do the job. And let me go like this, like this. So that's how we have the graph passing through this point, and this point, passing through 0, 2, and 3. This is top right, this is bottom left, and that's how this graph is formed. Now just acknowledge if this method is all good, all clear. Let me pause the recording and share all these images with you so that you can first copy it down. Take around like 7 to 10 minutes, and then we will go over another example. So now let's continue and let's draw another graph. Let's say the graph after factorization is y is equals to x, and this is 2 minus x, and this is x plus 3. Now, first of all, this x is positive, this x is negative, this x is positive. That means the coefficient of x cubed is negative. Let me go back and remind you that the graph will be like this. It's starting at the top left of the grid, and it will go till bottom right. So now let me draw this graph, and then of course there are roots of the equation. The second thing, that is about the roots. X-intercept, that means y is equals to 0. It's already factorized. X, 2 minus x, x plus 3 equals to 0. Therefore, x is 0. 2 minus x is equals to 0. And we have x plus 3 equals to 0. Therefore, x is 0, x is 2, x is negative 3. So these are the 3 roots. So now it's time to bring out the grid. And the grid is right over here. This is 0. That's over here. Hold for a second. This is 0. This is 2. And this is negative 3. So the negative 1, negative 2, negative 3, that's right over here. And it has to pass through these 3. At the same time, the coefficient of x cube is negative. That means it will start with top left and it will go till bottom right or vice versa. So now it goes like this, and like this. That's how the graph is drawn. It has to pass through the roots. At the same time, top left, bottom right. That's how the graph is drawn. So let me just draw portions of this graph step by step. So first of all, let me draw something like this, and then something like this, and like this, approximately, and like this. So that's how the graph of y is equals to x, 2 minus x plus 3 is drawn. This is top left, this is bottom right. It's passing through these 3 points. This is the first point. Let me mark it. This is the first point. This is the next point. This is the third point. So that completes. Let me label it. This is lecture number 18, and we are on the same PDF. So this is lecture number 18. That is thoroughly about cubic equations, and that is about its roots, the shape of the graph, and a basic transformation, whether it's translation up and down, or it's about the stretch parallel to y-axis. So that is the idea of lecture number 18. That's all about the cubic equations, the cubic function. Till the next class, take care.